This is part 2 of the reviewer guide. Part 1 covered the instrument and the panel, the quick start, the 6-method bake-off, and the 25 rater panel that carries the headline. If you are arriving here first, the short version is this. Those raters fuse two personality factors that Hexaco exists to keep apart, and the fusion collapses on characters the models have never seen. Part 2 is where that claim gets tested. It covers the substrate and everything downstream from it, the synthetic characters, the cache map, the register-matched control, the human anchor, the activation probe, and the cheap regressor. The rules are the same. Everything here reproduces from the public companion repository, from cached artifacts, at zero cost, and with no API keys. If a number on screen disagrees with the paper is authoritative, and we would like to hear about it. Notebook 4 builds the register-matched synthetic substrate, the decoupled control at the heart of the paper. 20 original characters are generated, with the fusion engineered to be absent. Version 0 holds the labels the language model set. Version 1 is where a human-curated pass would land, and the curation workspace shows 20 entries staged for that review. The critical design number prints on load. The designed correlation between honesty, humility, and Hexaco agreeableness across these 20 characters is negative 0.744, where the canonical characters come back from the raters fused near positive 0.75. They are pulled apart on purpose. The archetype counts split into 3 groups. 9 characters are aligned. 6 are sincere but harsh, high honesty humility with low Hexaco agreeableness. 5 are charming but crooked, the mirror corner, low honesty with high agreeableness. Those 2 off-diagonal corners are the ones the human corpus almost never contains, and the scatter plots make it visible. The synthetic points sit exactly in the corners the natural fusion leaves empty. Each per-character card pairs the designed targets with the opening of its evidence pack, so you can see the honesty and the harshness living together in one blunt quote. Then the decisive cell, label propagation. The cheap regressor and the Hexaco head never saw these characters, yet watch what travels through the training labels. The cheap regressor recovers openness at plus 0.8, conscientiousness at plus 0.63, and extroversion at plus 0.67, but fails on agreeableness and neuroticism. And the punchline? The Hexaco head predicts honesty against agreeableness at plus 0.84, sign reversed from the designed negative 0.744. The fused moral axis is not measured from behavior. It is copied from the labels. A reviewer or researcher can design their own decoupled character and confirm it lands out of cache, with a maximum cache similarity of 0.39, novel territory the training corpus never covered. Notebook 5 is the cache membership map, the robustness backbone of the whole argument. It starts from 1981 canonical characters, plus the 20 synthetic ones, and it scores every character's text against that corpus to ask one question: is this character in the cache or out of it? The gauge separates them almost completely, an area under the curve of 0.99. In-corpus characters sit at a median maximum cosine similarity of 0.87, the out-of-corpus synthetics at 0.41, and a threshold near 0.55 catches every synthetic, while false flagging 2.3% of canonical characters. Take that 0.99 as an upper bound rather than a deployment number. It was measured on a contrast built to be separable, and on naturally occurring characters, you would recalibrate the threshold on your own domain. Then the embedding projection lays the corpus out in 2 dimensions, novels in one region, plays in another, and the 20 synthetic characters in their own pocket that the canonical corpus never reaches. Read that panel as illustration only. Projections like it are good at showing you a shape and unreliable for measuring a gap, so the claim does not rest on it. The claim lives in the similarity distribution, not in the picture. The closing figure is the sign flip. The 20 synthetic characters were authored with honesty and agreeableness pulled apart at minus 0.74. The bar chart asks what each downstream method does with them. A regressor trained on the rater's own labels comes back at plus 0.84. SCPI retrieval, the purest retrieval method, which fits nothing and simply hands a character the traits of its nearest labeled neighbor, is the most extreme, at plus 0.92. Only the author-designed truth stays decoupled. Every instrument that leans on the cache inverts a correlation that was engineered into the data with the opposite sign. That is the contagion result from video 6, seen from the substrate end. Anything supervised by these labels, or retrieving against them, inherits the cached prior, rather than reading the page. Notebook 6 is the register-matched control. A reviewer could object that the synthetic characters fail only because they are written in a modern voice the corpus never saw. So this notebook regenerates them as period-accurate pastiche in 19th century diction, Austen, Eliot, and Dickens style, under the same author-designed decoupling. 10 new characters, designed at minus 0.704, and the novelty control flags 0 of 10, so none of them accidentally echoes a real character. Then all 3 substrates go to the same 3 frontier raters under the identical probe with names redacted. The canonical sample fuses at plus 0.65, replicating the published panel. The modern synthetics fall to minus 0.13. The period-accurate set lands at plus 0.02, essentially 0. Period prose does not restore the fusion. 2 of the 3 raters go negative on the synthetic sets, partly recovering the designed anti-correlation, which is what you expect when the fusion is absent and the rater is actually reading the text. The scope is honest. 3 raters, small samples, wide intervals, a focused replication rather than the full panel. Style is ruled out. The collapse is about what is in the cache, not how it is written. Notebook 7 establishes the human reference. It asks a simple question. In a large human sample, how correlated are the honesty, humility, and agreeableness axes? And it uses that number to judge the models. The human IPIP between-person correlation is plus 0.450 from 22,299 respondents, with a confidence interval of 0.44 to 0.46, read straight from the committed artifact. A second cell reproduces it from the public IPIP data with no cached shortcut and recovers the same value, so the anchor the paper leans on is reproducible from raw human responses. Now compare the models. In cache, on the canonical characters, they sit at plus 0.449, essentially at the human level, though the estimans differ, human between person against model across character. Out of cache, on the synthetic characters, the correlation collapses and reverses to minus 0.33. That is the point of the whole notebook. When a model reads the text, it lands near the human anchor, and it recovers the designed negative structure when that is what the text contains. The fused judge mode correlation near 0.75, seen elsewhere in the paper, sits far above the human 0.45. That gap is the inflation the whole paper is about, pinned here to a human-derived baseline. Notebook 8 is the mechanistic probe. The paper's look under the hood. It reads internal activations from open-weight models to ask a sharper question than any behavioral test can. Where does the trait fusion actually live? In the representations or only in the readout? The header frames the full sweep at 12 open-weight models, 7 to 72 billion parameters, including 3 at frontier scale. Llama 3.1, 70 billion, QN 2.5, 72 billion, and Mixtral 8 by 22 billion. The core linear probe runs on 8 of them. For each model, at sampled layers, the probe recovers honesty, humility, and hexaco-agreeableness from the hidden states. The first result. Both traits are linearly decodable from early and middle layers, with recoveries in the 0.6 to 0.77 range. So the models do encode these factors internally. They are not inventing them at rating time. Now the dissociation the notebook is built around. At rating time, across the 25 rater panel, the two factors fuse at a mean absolute correlation of 0.743. In the probed layers, the entanglement gap stays near 0.05. The factors look separable in the latent representation and fused at rating time, which points at the output mapping rather than the geometry. The notebook is careful about how far that goes, and so are we. The probe targets are model-derived, so the probes are trained on an already fused target. The probed models, at 7 to 9 billion parameters, do not overlap with the frontier raters. And read a different way, on the predicted value correlation rather than the accuracy gap, the shallow layers are fused at about 0.75 and separate with depth, which is the reading the paper reports. Both readings are in the artifacts. So this is consistent with post-training output mapping as the locus, not proof of it. The behavioral falsifier carries the claim. The probe says the story is at least coherent with what is inside the network, and it stress tests that by absolute layer, by relative depth, and with a dense versus mixture of experts contrast. Notebook 9 is the capstone, the interactive view of the catch. The setup cell loads one cached artifact and prints the scope, 60 characters, 12 models with depth trajectories. It runs at $0 with no API keys, and every figure is a live chart you can hover. Figure 1 is the money shot. For 3 independent 70 billion plus families, the y-axis is the correlation between predicted honesty humility and predicted hexaco-agreeableness. The x-axis is layer depth. The dashed line is the rating time fusion, about 0.74, what the model gives you when you simply ask it. If the model were measuring, that subspace would stay separable all the way down. Instead, every trace starts high and collapses, some flipping negative in the deep layers. Quen 2.572b drops by 1.05, the cleanest. Llama 3.170b by 0.56. Mixtral 8 by 22b by 0.23. The surface says one thing, the deep layers another. Figure 2 takes this to the smaller 7 to 9 billion raters. Color is the entanglement gap, how much better a joint probe over both factors does than 2 independent ones. Layers run left to right, 1 row per model, base and instruct labeled. Any cell gives its exact value, and the effect is noisier here than at 70 billion plus. Figure 3 asks where the subspace lives. Grouped bars compare 2 architectures across pooling strategies, with the early minus late fusion delta on the y-axis. The dense Llama 70b shows a large delta under mean pooling. It localizes the subspace. The sparse mixture of experts mixtral spreads it instead. Dense localizes, mixture of experts distributes. Figure 4 is the tie-in, internals meeting behavior. On canonical characters, the ones in the cache, the fusion sits at about 0.74. On 20 synthetic characters, absent from any training corpus, same models, same probe, it falls to about 0.29. A delta of minus 0.451, BH-adjusted P of 7.5 times 10 to the minus 8. Take away the cached prior, and the fusion goes with it. Notebook 10 runs the cheap regressor at inference time, the language model-free instrument the paper recommends for deployment. It is a ridge model over OpenAI text embeddings, embedding only, with 7-factor outputs sliced to 1,536 dimensions from the 3,072 native ones. No model calls at all, and the whole notebook runs at $0 with no API keys. Section 1 locates the data bundle. 3 files report OK: the leave one book out results, the regressor pickle, and the regressor metadata. No language model is loaded here, only cached artifacts and a fitted linear model. Section 2 is the headline. Under leave one book out cross-validation, the mean absolute error is 0.3117, with a 95% bootstrap interval of 0.302 to 0.322 across 2,000 resamples, over 576 characters, and 75 works. The comparison line matters. The distillation baseline is 0.309, and this run's mean sits inside its confidence interval. So the language model-free instrument is statistically indistinguishable from the distilled one, at roughly 61 times lower cost, about 6 cents per character down to about 1/10 of a cent. Section 3 breaks the error down per book, and the pattern is practical. The 5 hardest are short-cast plays with only 1 or 2 characters, The Merchant of Venice worst at 0.58. The 5 easiest all carry 10 characters. More characters per book means a steadier reading. Section 4 is the reproduction stub. It stays in no-op by default and prints how to regenerate fresh embeddings with an API key, or to run the packaged leave one book out script. Nothing here costs money unless a reviewer deliberately opts in. This is the deployable floor, and it inherits the paper's central split cleanly. The openness, conscientiousness, and extroversion factors transfer off cache because they lie off the fused moral axis, while honesty and agreeableness carry the moral axis entanglement forward from the training labels. For a practitioner, the message is exactly the recommendation. Use the cheap regressor at scale for the factors that generalize, and treat the moral axes with the caution the rest of the paper earns. That is the walk, and the end of both parts. If you have 2 minutes, the README opens with the short path. 2 files, 4 numbers, no API key, and no notebook. If you have 30, start at the reproduction map, which routes every research question to its notebook. Run notebooks 3 and 9 for the headline numbers, and check any figure against the panel 25 directory, regenerated deterministically at seed 42. The objections file maps every objection the paper anticipates to the artifact that answers it, including the 2 it cannot answer. If a count ever looks off, the roster history explainer reconciles every panel size we ever used, and the substrate explainer maps both synthetic batches to the raters who scored them. Code is MIT. Data is Creative Commons. One thing worth saying plainly, these notebooks verify results. They do not reproduce the pipeline that produced them, and the README now says where that line falls. If a number here disagrees with the paper is authoritative. File an issue. That is what the companion is for. Thank you for watching.